In this video, we're going to look at some very basic right triangle trigonometry and one application. Now we can define the trigonometric function several ways. One way is what I'm going to do here using a right triangle. You can also use the unit circle, and you can also use the idea using the angle in standard position. If you know a point on the terminal side of an angle in standard position, you can also find the value of a trig function, sine, cosine, whatever. So for this one here, I have a right triangle, and the sides of the triangle are A, B. Those are called the legs, and C, which is the longest side, always opposite the largest angle, which is of course 90 degrees, is the hypotenuse. So we define the trig, so we know this angle theta here. Then B is the opposite side, A is the adjacent side, and C of course is the hypotenuse. So we can say the sine of theta is opposite over hypotenuse, or B over C. Sine or cosine of theta is the adjacent side A over the hypotenuse side C, and the tangent opposite or adjacent, or B over A. And those are the main trig functions that you need to work problems involving right triangles. But we'll go ahead and include what we call the reciprocal functions. The cosecant of that same angle theta is just the reciprocal of what we get for sine of that angle. Instead of B over C, it's C over B, or hypotenuse over the opposite. For the secant of angle theta, instead of A over C, it's C over A, or hypotenuse over the adjacent. And the tangent of this same angle theta, or I should say cotangent of theta, instead of B over A, it's A over B, or adjacent over the opposite side. So notice that the sine and the cosecant are reciprocals. One you get a value of B over C, the other one C over B. Cosine and secant are reciprocals. One has value A over C, the other one C over A. Tangent and cotangent are reciprocal. One has value of B over A, the other one A over B. So if you know the value of one, you know the value of the reciprocal function. When working with triangles, besides using the trig function, sometimes if you're given all three sides, or you're given two of the sides, you can find the third using the Pythagorean theorem. So as an example, suppose that side B has a value of 8 units, and A has a value of 5 units. And the problem was to find the hypotenuse, length of the hypotenuse. Well, we use this formula. For a right triangle, the square of the hypotenuse, or the longest side, is equal to the sum of the squares of the other two sides, or the legs. So in this case, we would say C squared is equal to 5 squared plus 8 squared. So that'd be 5 squared is 29, 25 I should say, and 8 squared is 64. We'll add these up, we get 89. C squared is 89. Take the square root of both sides, so we get the length of the hypotenuse here as the square root of 89. And if they ask for an approximation, you can go ahead and use your calculator and take the square root to whatever places they tell you. But that's one basic use of the Pythagorean theorem. Now let's look at how we can use this in a basic application problem. From a point 120 feet from the base of a building, the angle of elevation to the top of the building is 55 degrees. How tall is the building? So let's say this is the height of the building. Let's call that X. And this point over here, say, is 120 feet. from the base of the building. That's right here. And this angle of elevation with the horizontal to the top of the building is 55 degrees. So here I can't use the Pythagorean theorem, so I have to use one of the trig functions. Now which one you use depends on what you're given. So for the cosine of 55, that would be the adjacent side over the hypotenuse. Well, the hypotenuse is not given. Can't use the sine because that's opposite over hypotenuse again. So the only option I have here is to use the tangent or cotangent, because they're the same pretty much, except they're reciprocals. So I just say the tangent of 55 degrees is equal to the opposite, that's x, times the adjacent side, that's 120. This is feet. And then you solve this equation for x, solve it for x. So what we do here is isolate the x, so we multiply both sides by 120. Multiply by 120, and these are going to cancel. So x will equal to 120 times the tangent of 55 degrees. So now I just compute the tangent of 55 degrees, multiply by 120, and that will give me the height of how tall the building is. Now the angle is given in degrees, so make sure that you check, because you can be dealing with degrees or radians. So we go to mode, and we want it in degrees. So it has it in radians. So I go down over to degrees and hit enter. There we have it. So now I just take 120, and that's going to be times the tangent 55. And notice, since I have the calculator set to degrees, I don't have to put a degree there in the 55. Calculator knows that that's tangent of 55. Hit enter. So I get 171. I'll round it out to one place. 0.4. And this is in feet. Thanks for watching. We'll see you next time.